my past and current research program was largely dictated by or put into place by my training in graduate school, which started out at the University of Alaska in Fairbanks, where I got a master's degree in wildlife management. And I went on to get a PhD in ecology at the University of Pennsylvania. And those two graduate training experiences really prepared me for a career in avian ecology, specifically physiological ecology of birds, with an emphasis on seabirds. And I've pretty much kept that, although as my career has progressed, I've done less and less basic curiosity-driven research and more application-driven resource management relevant research. My most significant contribution to ornithology, in my mind at least, is the importance to seabirds, and particularly seabird reproduction, of diet quality, of the types of prey that seabirds select at sea during the nesting season, and the relevance that that has for their reproductive success, their life history strategies, and in particular, the discovery, which I was involved in, of wax esters and the importance of wax esters as a biogenic lipid and an energy source for seabirds, which really have very high energetic requirements during the breeding season. And before my research was conducted, it wasn't known that seabirds could even digest wax esters. It wasn't until we showed that they could, and they relied on them heavily, that we knew how important they were to the reproductive energetics of a number of seabirds. I think the thing that I'm most proud of having passed on to my students is a sense that they can both conduct good scientific research that's well-founded in the scientific method and provides additional information for ornithologists as scientists, at the same time that they can provide information that's relevant to policymakers and natural resource management decision makers, so that they can actually walk this fairly fine line between curiosity-driven science and application-driven science, and do a good job at both. What I've learned most significantly from my students is that they can get that very fine line of walking between application and curiosity-driven science and do both well. And that's something that they can actually pick up in graduate school. And a number of them have applied that in their subsequent careers. My most memorable experience in the field most recently was taking a boat out from the mainland of China to an island where we were trying to restore a colony of Chinese crested terns, which are critically endangered. There's less than 50 of them left alive today, and discovering, along with everybody else in the boat, that not only had a large tern colony formed on our restoration site off the coast of China, but that there were 19 Chinese crested terns in amongst them, and it was completely unexpected. It was a real high moment in my career with seabirds. The question of whether I would change anything again if I had my career to do over again, that's always a tough one to answer, because in many respects I feel very fortunate to have had the career that I've had so far. It's not over yet, but I'm fairly pleased with being able to pursue my interests at the same time as I've had a professional career in ornithology. I think maybe one thing I am a little wistful about is that I haven't spent more of my time doing research on birds in Africa, in particular southern Africa, where there's a wealth of avifauna with many unanswered questions about their ecology and breeding biology. The most challenging scientific controversy that I've been involved in is probably the one that I'm embroiled in right now at the mouth of the Columbia River with the management of fish-eating birds that are consuming significant numbers of ESA, or Endangered Species Act listed salmon and steelhead coming out of the Columbia Basin. And that's been challenging because not only has it been a very complex scientific issue, but it's also been extremely complex in terms of the stakeholders involved in the decisions that would be made about managing fish-eating birds at the mouth of the Columbia River. It's really been one that's tested my ability to walk the fine line between conducting good science and being an advocate for a particular policy or management outcome. I think my thinking about that particular issue of managing fish-eating birds at the mouth of the Columbia River has evolved in the sense that I've realized how difficult it is to both do good science and portray that good science in an objective fashion, and also conduct myself in a way that I feel is consistent with my personal ethics and moral beliefs about the importance of conserving the natural resources that fish-eating birds represent. I think the most rewarding aspect of my career has been training graduate students. I think working with graduate students, seeing them grow as individuals and as scientists during the graduate school experience, it was certainly a major transformation process when I was a graduate student, both at the master's and the PhD level, and seeing other students following behind me that I'm involved with training and mentoring, seeing them go through those same transformations has been really rewarding to me. The most challenging aspect of my career has been feeling like I've done an adequate job at advocating for the conservation of avian biodiversity at the same time that I'm conducting objective science. I think the greatest challenge that is facing ornithologists today is to keep as much of the avian diversity that currently exists on this planet in place and available for future generations to see and enjoy and experience. That, given the rapidity at which humans are transforming the planet currently, it's going to be a major challenge to keep even half of the species of birds that we currently have on the planet here for another few centuries.